Yeah, somebody has recorded, right? Yeah, somebody started recording.
Yes, so someone has started the
Yeah,
recording.
yeah, fine, fine. Okay, okay, okay. So in this course, we have this is the syllabus like the starting introduction and fundamental concepts of thermodynamics. Okay, then we will be moving towards some other concepts like what is zeroth law of thermodynamics, what is first law of thermodynamics, what is second law of thermodynamics. Okay, and concepts of energy, hmm, and even some part like entropy. Okay, and then some basic cycles like Carnot cycle, Rankine cycle, okay, diesel engine cycle, Otto cycle, and even Joule cycle. These are all different cycles actually, and even a Rankine cycle, which is a thermal power plant cycle. Okay, these all cycles we will be reading. So I would like to suggest these two books over here. Apart from this, I'll be following other book which is most famous, Singer Basic Thermodynamics by Singer. Okay, that book also you can follow. So in my class, I'll be adding text from this particular book. Okay, wherever I'm suffering from the images and all, then I'll be borrowing some images from Yunus Angel book also. Okay, so my slides will be combination of both this present book as well as Thermodynamics by Yunus Angel. Okay, so today let us start this introduction, fundamentals. Okay, and what is system, what is surroundings, what is boundary, what are the processes, okay, what are the units, why should we, okay, these are the things. Thermodynamics, this is actually a Greek word. Thermo means heat, okay. Dynamics means anyhow dynamics nowadays, that is also English word, okay. Totally heat dynamics or heat force, how it is acting, what it is generating, okay, how we are using it. Based upon that, what are the day-to-day appliances we are using. Okay. These are all the things derived from thermodynamics. Okay. So broadly, we have classified here three ranges. One is like conversion of heat energy. Yes. So by converting certain heat energy, then we will be getting some mechanical power. Okay. But anyhow, that heat energy is produced from some other sources like chemical energy. Okay. What is the chemical energy? Heat you cannot get directly, as you know. Okay. You have to burn something. Yes. If you burn some wood, then only you will be getting your bonfire. Yes. If you burn some kerosene, okay, then only some kerosene stoves are burning. If you burn some LPG, then only cooking stoves are burning. Okay. These are the day-to-day appliances we are seeing that is generating the heat. Okay. In case of electrical energy, whatever we are using day-to-day life, how it is producing. As you know, some part is from renewable energy. Okay, but anyhow, that part is very small, including solar, wind, and hydro. But major portion, whatever the major portion, like 59 or 58 to 62% is coming from fossil fuels like burning coal, or burning certain gaseous fuels based upon that particular nation's fuel resources availability. Okay. We Indians have so much of resources of coal. That's what we are burning the coal. Okay. That means whatever the chemical energy involved in that coal, once you burn, that is transforming to heat energy. Then that heat energy you will be converting into mechanical energy. Then that mechanical energy is converting to electrical energy. Yes, we are going to see everything. This is about conversion of heat energy and producing cooling effect. Okay. That is like whatever air conditioning systems you have, including AC, okay, air conditioning system and refrigerating system in your home. Yes, nowadays in every home we have these two, air conditioning system as well as refrigerating system. These two systems also working on thermodynamics purely. Okay, even these are the applications purpose. The third one is with different thermodynamics properties, we will be generating some sheets, some data, and then we will be using everywhere, wherever we need. Okay. So broadly, whatever three classifications we have done, okay, when you count applications wise, you can see individual components here, like automobile engines. Okay. Automobile engines, you have diesel engine, yes, a petrol engine, and even CNG engine. Yes, these all are running upon certain thermodynamics based cycles. And turbines, which turbines? Gas turbines. Where do we use gas turbines? In case of aircrafts. Okay, in case of aircrafts. And even whatever your hydrothermal plant, hydropower plants. Okay, hydropower plants. There actually fluid mechanics part is dominating. However, everything fluid mechanics as well as thermodynamics, okay, and heat transfer, these all are connected together. But the basic subject is from thermodynamics. Okay. And even you have compressors, okay, and even pumps. Pumps means which from whatever the water lifting pump. You have municipal water in the sump. That water should be lifted to the overhead tank. Okay. That anyhow involved with fluid dynamics, but whatever the process we will be saying over there, that process is related to thermodynamics. Okay, and even compressors, which compressors? Many types of compressors are there, like air compressors. Okay, when there is no air or otherwise pressure is very less, in case of your cycle tube or your motorcycle, okay, or your car, then immediately we will be going to the that puncture wala, patch wala. Okay, he has one compressor, right? That compressor obviously running upon the basic thermodynamics. Okay, and even power plants as well as coal power plants or gas turbine power plant or otherwise nuclear power plant. Okay, these all are running upon these all the things. Combustion systems, cryogenic systems, heating and ventilation, air conditioning. Okay, and heating pumps, cooling pumps. Okay, even magnetohydrodynamics. Okay, whatever, wherever fluid is involved, that fluid is underpassing to the certain temperature change as well as certain pressure change. Okay, okay, wherever the fluid is involved in particular system or in particular equipment, that fluid's temperature and fluid's pressures changing frequently. Okay, according to the certain cycle. Okay, what is cycle and all we are going to see anyhow. Okay, then we can consider their thermodynamics is the dominating part. Okay. So now let us see what are the components we have discussed. What are the components we have discussed so far? Many times we have mentioned the engines, gas turbines, thermal power plants, yes, air conditioning, refrigeration system, yes, these are. And also, these parts we will be using in the thermodynamics. Anyhow, the cycles and all, what cycle it is working, how it is working, these all are coming at the end chapter. Okay, at the end chapter. There we will be learning about individual component and even individual cycle, how it is working. But before that, throughout our subject, wherever certain problems are coming, certain discussions are coming out, then we will be using the word a refrigerator, okay, or a gas turbine engine, or a thermal power plant, okay. This kind of terminologies you will be finding out somewhere. But why should we be in such a ambiguity? What is happening in case of gas turbine? What is happening in case of thermal power plant? Why should we learn at the end? Yes, no need. Let us discuss over here. Okay, even not very elaborately. Even we are not following the technical aspects like cycles and all, because with the prior knowledge only we have to go to that end chapter. Here, let us discuss in terms of such a story kind of thing, otherwise nothing. Okay, such a story kind of thing, how it is working. Okay, that let us see. The first thing is turbojet engine or gas turbine engine. Whatever you are seeing in case of your flight. Okay, below the wings of the flight, you might have seen on the both the sides very big to circular parts, cylindrical parts. Yes, certain fans are rotating at very fast. Okay, that is your gas turbine engine. That engine only providing you the thrust. Okay, whatever your aircraft is running. Okay, that much of thrust is provided by that engine. Let us see what is happening over here. So whatever the front portion, you will be able to see one big fan is rotating, right? That fan is this. Okay, that fan is this. Okay, so that we can call it as compressor over here. Okay, what is the purpose of compressor? The name itself is saying it should compress certain things. Okay, that means what it is doing, it is I'm sorry, it is absorbing certain amount of air from the atmosphere over here. Okay, it is sucking. Then it is compressing. Compressing means the simply reducing the volume, increasing the pressure. Okay, compressing means reducing the volume and increasing the pressure. Okay, so then it is reducing the volume and increasing the pressure of certain air, whatever it has been sucked from the environment. Then this is the compression process. Then this compressed air is passing to these combustors, 1, 2. But here, since it is the cross-sectional cutting way, it is showing you 2 compressors. But actually, since this is the cylindrical, okay, in case of aircrafts, we will be having 8 number of combustors. Okay, these we can call simply can combustors. Okay, and then this high pressure and high temperature. Why we are calling high pressure and high temperature? You have compressed it. So somebody's mic is on. Can you please keep it off? Yeah. Can you please keep your mic in mute? Everyone, please check. Okay, thank you. So the purpose of compressor is to compress. So when volume is reduced, when pressure is increased, obviously temperature also will be increasing. Okay, that means high pressure, high temperature, air is reached to the combustor. Here, certain amount of the fuel, okay, that is aircraft fuel, is injecting over here. Okay, injecting over here. So obviously, what is happening? That fuel has chemical energy. Okay, when it is burning, it is releasing certain heat energy. Okay, certain heat energy. So this combustor is, what is the purpose of combustor? converting the chemical energy into the heat energy. Okay, very nice. So at the end of the combustor, we have high temperature, high pressure, okay, gases, okay, that we can call combustion gases, whatever. Then these gases we are passing upon turbines, okay. Here for the image purpose, we have shown only 2 rows of turbine blades, but maybe might be even many rows of these turbine blades also, okay. We'll be expanding this high pressure, high temperature combustion products upon the turbine. So what will be happening in the turbine? This pressure energy is converting to the kinetic energy. Okay. Then this is rotating the turbine. Okay. Turbine is rotating. That means what is the purpose of turbine? Converting this heat energy into the mechanical energy. Okay. What are we doing over here? Chemical energy is converted to heat energy. This turbine is doing what it is doing. It is converting heat energy into the mechanical energy. But here in case of this gas turbine engine, certain part of heat energy only converting into the mechanical energy. How much part? Whatever is sufficient to run this compressor. Otherwise, how this compressor will be running? This is connected to this. Yes. Then rest of the part we are passing through the nozzle. Here if you see, this is nozzle. Okay. This is the nozzle. So what is the purpose of the nozzle? When high pressure gases are passing through the nozzle, it is developing certain thrust. Okay. That thrust itself is pushing your aircraft ahead. Okay. The thrust itself is pushing your aircraft ahead. Okay. So this is the compressor, this is the combustor, this is the turbine, and this is the nozzle. Okay. Only part of the energy only converted into mechanical energy. Rest of heat energy is useful over here to generate a thrust. Okay, the thrust itself is driving your aircraft. This is about turbo engine. Okay, or otherwise gas turbine engine. The next, let us move to the thermal power plant, whatever we have over here. Okay, thermal power plant. What is the fuel in the thermal power plant? Can anyone answer?
Coal.
Coal in case of India. Okay, so even certain places we are
Sir, in
running
the
gases. Yeah, please.
sir, in the turbojet engine, why
Uh,
are we like heating the gas, heating the compressed gas? Why is it necessary? Like compressed gas can also rotate turbine.
Compressor, yeah, that is the natural phenomena, right? When you are compressing, obviously temperature also increasing. We are not heating by adding certain heaters. We are compressing. That is the reason temperature also increasing. Pressure is increasing, so temperature also increasing.
Oh, by any other external source, we are not
No,
increasing.
no, no, we are not using. We are not using. Okay.
Okay.
So by the thermodynamics laws, whatever the Boyle's law, Charles law, whatever we have, so we are compressing. Since pressure is increasing, temperature also increasing. Okay. Yeah. You can ask me if you have any doubt in between also. I don't have any problem. Okay. So now let us move to our part, thermal power plant. Okay. So we have so much of resources of coal in India. So we are using coal as the major source for our thermal power plants. However, it is producing so many emissions like carbon dioxide, carbon monoxide, sulfur oxides, because coal has so much of sulfur. Yes, that we cannot separate it even. Yeah, there is no such process so far because the coal itself is the huge component, right? Yes. So sulfur dioxide, okay, and also certain soot particles, certain particulate matter, okay. But however, to meet the energy demand of the nation, okay, so we should burn it. Okay, so that's what nowadays our focus is going upon the different renewable energy sources. Yes. So anyhow, that is another thing. Okay, that let us discuss sometime later whenever it is required. Okay. Now let us focus upon our thermal power plant. These all are power generating equipments, whatever your gas turbine engine, even the gas turbine engine, in case when you want to use gas as the fuel, okay, if your nation has so much of the gas or liquid fuel, okay, instead of thermal power plant to generate the electrical energy, we can use gas turbine engine also. Okay, the countries like US, Russia, and Gulf countries, okay, they have shale gas and they have so much of liquid fuels, yes, because even in case of Russia, they have so much of natural gas, okay, so they have so much of resources, okay, so this is actually a very big process. Here, thrust generation is not required. When you are using this particular gas turbine engine for electric energy generation, this component will be minimized, okay, and here to this turbine, one generator will be connected. What is the purpose of generator? Okay, it is converting mechanical energy into the electrical energy. Okay, you might have seen many generators, okay, like for standby during marriages and all, or any functions and all. So we usually borrow, or otherwise we usually take upon rent certain generator. What it do? What is the purpose of that? So one electric magnets, whatever that will be connected to the diesel engine. Yes, when diesel engine is running, that is generating mechanical energy. That mechanical energy is converting to electrical energy in the generator part. Yes, yeah. So like that, here the same gas turbine, whatever the gas turbine engine we have, we can connect the same shaft by extending over here to the generator part. Okay, so then it is producing so much of electrical energy. This is possible whatever the nation, if the nation has certain gaseous fuel or liquid fuel. Okay, in our country we have so much of coal resources. That's what we are depending upon this particular thermal power plant. Okay, so now let us see this process, what it is doing. Okay, see here, this is the boiler, we can call this complete thing. Okay, boiler. The purpose of the boiler is here actually in case of our thermal power plant, the processing fluid is steam or water. Okay, the processing fluid is steam or water. So initially, when you are burning the coal has so much of chemical energy. Once you start burning this, that chemical energy is transforming to heat energy. Okay, this heat energy is absorbed by this water in these coils. Okay, then that water is transforming from liquid phase to the gaseous phase, that is steam. Okay, then here by absorbing the heat from the coal burning, this water is transformed to the steam. That steam is at high pressure and high temperature. Okay, this high pressure and high temperature steam we are injecting upon the steam turbine. Here we have steam turbines. Okay, sorry, the blade arrangement and even structure would be different from this gas turbine turbines. Okay, this is the gas turbine. Okay, it means and even this is the steam turbine. Okay, these both are certainly different from each other. When steam is expanding upon this kind of turbine over here, then mechanical energy is generated. This mechanical energy, whatever this shaft is rotating at certain high RPM, okay, then it is generating electrical energy by cutting this EMF over here. Okay, electromagnetic flux. Okay, it is generating electrical energy. Anyhow, that electrical energy is reaching to our home or industries wherever we want, like this power supply cables. Okay, and here, whatever the steam is coming out of the turbine, still that is in the gaseous stage only. Okay, then that steam is passing to the condenser over here. This we can call condenser. The name itself is saying condenser. Okay, what is the purpose of this? It is condensing. That means phase change again happening over here. This is the steam. That steam is coming back again to the liquid. Liquid means water over here. That water again pumping back over here. Okay, water pumping back. That water again taking the heat energy from the coal and becoming superheated steam. Okay, means high temperature, high pressure steam. Then it is impinging upon this. Okay, in between we have pump also over here. Okay, we will be putting certain pump over here. That pump, because this is what is the process we are doing over here in the turbine? We are expanding. Expanding means pressure is reducing. It is high pressure to the low pressure. Okay, but boiler is running at high pressure. Yes, so to send this liquid from low pressure to high pressure, okay, then we will be using certain pump over here. This is the process. But anyhow, at the end chapters, we will be discussing elaborately about these all the things. Okay. Now for the understanding, if in the due course, means when I am explaining chapter 1, chapter 2, chapter 3, if I simply say a condenser in the thermal power plant, okay, you have to imagine it, otherwise nothing. Okay, so that is the reason I am explaining over here before jumping to the actual topics. Okay. This is your engine. Okay. This is your engine, automobile engine which you are using. This is over here we have spark ignition engine. Okay, spark ignition engine, like petrol engine, whatever you are using in case of your car. Okay, what is happening over here? Here we have four processes over here. See here, this we can call piston, and this we can call cylinder. This we can call connecting rod. This we can call crankshaft. Okay, this piston and crankshaft is connected by a crankshaft. Oh, sorry, piston and crankshaft is connected by a connecting rod. Okay, this is the piston and this is the crankshaft. Both are connected by a connecting rod. Okay, so now piston is going down. Okay, here see these red things we can call it as, this is the intake valve, this is the exhaust valve. Okay, this is intake valve, this is exhaust valve, and this is your spark plug. Okay. When here intake valve is open, how these all are opening, those all are actually you will be reading in case of your IC engines if you will be taking that course. Okay, so there is a certain camshaft and puppets. Okay, certain mechanism is there over there. According to that, these two will be open. Okay, so now intake valve is open and the piston is going down. That means here cavity is forming over here. Okay, since the piston is moving down, suction is created over here in this chamber. Okay, because of the suction created, this air fuel mixer is coming in. Okay, air fuel mixer. Let us assume this piston is reached up to this position. Okay, up to this position. Whatever this space is there, this space is completely filled by your air fuel mixer. Now, piston starting moving up. Okay, piston started moving up. When it is started moving up, the same time this valve will be closed. Whatever this valve is open here, right? When piston started moving up, this valve will be closed. Okay, And this valve anyhow was closed from the beginning. Okay, this is the exhaust valve. What is happening now? This gas is arrested in this volume, and piston is moving up. So that is the reason we can call it as compression stroke. Okay, it is compressing. Because of that, what is happening? Pressure is increasing. Obviously, temperature is also increasing. Okay, so now at the end of this particular stroke, okay, our mechanism is set such a way that the spark is ignited. This is the spark plug, right? Spark is ignited. Okay, what is there inside? This is the air fuel mixer. If air fuel mixer is there and somebody is igniting, will it be letting silent? No, it will be burning. Is it? The whatever fuel air mixer is burning. Once it is burning, what will happen? Pressure will be increasing a lot. Okay, tremendously. Pressure will be increasing a lot. Okay, but still, these two valves are still in closed position. Okay, but because of this burning process, whatever the fuel is burning, that is chemical energy is transforming to the heat energy. That heat energy is because of high pressure acting upon this particular piston and trying to push the piston down. Okay, that's what this is in a red color. It is trying to push the piston down. That's what we call it as power stroke. Okay, when it is going down. Now, in these two strokes, energy is adding upon this piston. Now, this whatever energy is generated over here, that is adding to the shaft again, back. Okay, it is moving down. Fine. Now, in the next stroke, whatever this exhaust, the piston is slowly moving up. Not slowly, whatever that particular speed is there. When piston is moving up, this exhaust valve is opened over here. Okay, this is completely exhaust gas. Okay, and then this gas is going off. This gas is going off means to your silencer. Okay, whatever in vehicle you have silencer, right? Tailpipe. Okay, going to that. And again coming back to this particular operation. Okay, intake, compression, ignition, okay, then power transmission, then pushing out those all gases out. And again intake, compression, power stroke, pushing all the gases to the out. This is the process happening in case of your petrol engine. The same process, instead of this particular spark plug, if you replace this with fuel injector, okay, diesel fuel injector, okay, then that is the diesel engine. However, one thing actually, these are for just for present remembrance, I am just telling. The spark ignition engines run at low pressure. Diesel engines run at high pressure. Okay. In case of diesel engine, so nobody is igniting over there. There is no spark plug kind of thing over there. Okay. That is auto ignition actually. That is auto ignition. Okay. Just don't confuse these other things. Just telling. So otherwise, in the chapter again, you will be seeing certain engine is operating this pressure, that pressure. Okay. So for your knowledge, I'm just mentioning these other things over here. Okay. And see, this is your refrigerator you have in our home. Yeah. You are buying something, simply opening the door and dumping that. Okay. And whenever you want, taking out and enjoying your food. And again, rest of the food you are dumping in. Yes. This is the process happening. What is happening over here? Here also there is certain thermodynamic cycle. Okay. Here also there is certain thermodynamic cycle. Okay. Here the working fluid is refrigerant. Okay. Refrigerants. Many refrigerants are there. Whatever chlorofluoro refrigerants. Okay. These are many refrigerants are there in ammonia absorption compression systems. Okay. Many things are there. Those all you will be seeing. There is an additional course for that, separate course, refrigeration and air conditioning. Okay. In that you will be studying anyhow. Okay, our part here, how this cycle is working, what is happening over here. Okay, that let us see. Okay, this refrigerant actually initially compressing over here. Okay, let us assume whenever it is compressing, that is in the gaseous stage. Somewhere we have to start the cycle, right? Cycle means this is the cycle round up. Okay, then we have to start at certain point. Okay, so that's what I'm starting over here from the compressor. Here it is compressing. The purpose of the compressor itself is to compress certain fluids. Okay, here the refrigerant whatever we have, before reaching to the compressor, let us assume this is in gaseous stage. It is compressed over here. Okay, and then this is because of the compressor. What's happening over here? Certain temperatures are increasing. Okay, this is condenser. Okay, what is condenser doing over here? The name itself is telling about that. Name itself is telling about that. Even we have seen in case of your thermal power plant, it is condensing, like phase changing. Okay, here this is the gaseous, right? Now here it is changing the phase. Okay, in your refrigerator, you might have seen at the back, at the down. Okay, down of your refrigerator, you might have seen certain radiator kind of thing. Okay, certain tube is with many bolts. Okay, okay. So like a small radiator kind of thing, whatever you usually see in case of car, right? Such a small radiator kind of thing you would have seen in case of your refrigerator at the back side. If you have not seen, now also you can see. Okay, that is the condenser. That is changing the phase. This gas is transforming into the liquid refrigerant. Now this liquid refrigerant is passing through the certain expansion valve. Okay, so here actually for our understanding we just have put here valve, this kind of thing. Okay, but otherwise this we can call throttle valve. In our thermodynamics we will be seeing that process also, throttling process. That is the free expansion process. Anyhow, we are going to see that. Okay, because of that this will be at certain low temperature. At the end of this throttle valve, the refrigerant will be at very low temperature. Then this cold liquid phase refrigerant is passing to the evaporator. Okay, this is only your freezing area. Okay, whatever food you are keeping, right, in that vessel. This is the vessel, simply a container. Inside the container, this evaporator is there. Okay, so what is happening over here? Whatever the food stuff you are keeping over here, this evaporate in the evaporator, this cold liquid phase refrigerant is absorbing the heat and it is transforming to the gaseous stage. Then finally, the fully gaseous stage, high temperature evaporated stage refrigerant is going back to the compressor. Okay, so just remember like that, and even after this class, you can one more time you can repeat the video. Anyhow, we were recording. Okay, try to understand in detail. So these are the major applications. The similar way, if it is closed container kind of thing, this is your refrigerator. Okay, if it in case of your air conditioning system, okay, this is indoor unit you can consider. Nowadays, every system is like this thing, right? Split AC. Okay, so whatever you are keeping inside the home, okay, that is this part. Okay, evaporator part you are keeping inside the home upon the wall. Okay, so your entire domain is room, very big room. Okay, so this evaporator is taking the heat from the room, and even this is liquid refrigerant is transforming to the gaseous stage. Okay, and then finally going back to the compressor. Okay. So that is happening in case of both refrigerator as well as air conditioning system at your home. Apart from these only the applications oriented. Apart from these, many things are there, like rocket propulsion system. Okay. So in the initial slide, we have given a big list. This is okay. Few things only we are explaining over here, but many things are there here to discuss. Okay. Okay. So let's see. Even propulsion system, rocket system, okay, and even your heart also, whatever. These all are working upon this particular thermodynamics. Okay. In your heart also you have pump. Okay. You have nerve system, and even you have blood flowing at certain pressure. Yes. It is circulating throughout the body. The only thing is actually this is only live system. Okay. It is the live system, but most of the things in even human body also, most of the things is matching with mechanical. Okay. Mechanical system like thermodynamics, fluid mechanics. Okay. With these all the things, even backbone and all coming under like solid mechanics. Okay. Okay. Mechanics part and all. Okay. Is about certain introduction. Okay, so now let's enter to the our part, thermodynamics part. Okay, so since this is the first class, as well as only 37 students are registered so far. Okay, so even our class is for 2 hours today, so I'll be taking only 1 hour or 1 hour 10 minutes. Okay, rest of the things let us discuss in the next class. Okay, okay. So why I have considered this particular book? Okay, whatever this book I have mentioned, right? This book. So this book is very famous book. Along with that, this book is explaining this thermodynamics in terms of mechanics also. Okay. So why should I worry about mechanics over here? Means you have studied mechanics in your first year BTech. Is it? You have idea about that. Okay. Here also we will be talking equilibrium. Okay. There also you might have studied equilibrium. Yes, in case of mechanics. Yeah. So like this, many things are coming up. Okay. So in mechanics, you will be taking a free body. Okay. Then after you will be finding out what all forces are applying upon that. Okay. Then after you will be applying Newton laws and all. Okay. Then you will be solving the problem. Is it? Same like thermodynamics also, as like you have free body in case of your mechanics. Here also we should have certain body over here. Yes. Otherwise, upon which what we will be studying. Hmm? Okay. So, as like free body over there, in case of our thermodynamics, we will be calling it as the system. Okay. The system. System means area upon which our focus to study this particular thermodynamics. Okay. That is the system. This is. There is no particular shape for this. Okay. That will be varying. Okay. System. Suppose in case of compressor, that small piston cylinder is 1 unit. In case of refrigeration, okay, the condenser, even whatever applications we have seen right here, okay. So this totally one thermodynamic system, or this compressor itself is one thermodynamic system, or part of the compressor itself is one thermodynamic system. The combustor is one thermodynamic system. The turbine itself is one thermodynamic system. Yes. Even this nozzle itself, one thermodynamic system. Like that, there is no particular shape. Okay. Even see over here, this is your steam generator. Okay, this shape is something different. Like that, there is no particular shape for this. Whatever the area or focus to study the thermodynamic aspects. Okay, that is the system. Fine. So whatever the surface around you have, okay, that we are considering it as boundary. Okay, that is boundary. Suppose your total body you are considering as the boundary, sorry, system. Okay, consider your total body as system. Then your outer surface upon the skin is your boundary. Okay, if you take water in a glass, okay, the outer surface of the glass itself is boundary. Okay, simple, that is. Then apart from the boundary, okay, that is surroundings. This is the very simple, as like your home. Okay, complete your home area, the floor area is yours, that is the system. The boundary wall which is separating from the others, okay, the boundary wall you will be constructing, right? That is the boundary. Okay, then whoever are neighbors, their surroundings, the same like that. Okay? This is the system, and boundary, and surroundings. Okay, the system, it is not anything like fixed volume or fixed boundary. Okay, in case of thermodynamics, it will be changing. Okay, yeah, like see, I'm considering balloon. Okay, I blowed it with full of air to the maximum level of expansion. Okay, then that is one system I am considering now. Okay, one big balloon, I have blown air up to the maximum capacity. Okay, and then I tightly hold it that mouth of the balloon. Okay, I'm not allowing to escape the air. That is my system. And the outer surface, whatever this thin elastic membrane of the balloon, that is your boundary. Okay, surrounding means apart from me the surrounding. Now, wherever I'm tightly holding the mouth, okay, now I'm releasing the air within the from the balloon. What is happening over there? Slowly air is escaping from the balloon. Okay, then balloon volume is contracting, right? Balloon volume is contracting. Then what is happening over there? The system size is reducing. Yes, the system size itself is reducing. That means the boundary can be flexible. That is not rigid. Boundary can be flexible. Same like that, based upon the application, wherever you are considering the system, okay, mass can be transferred either inside or outside. That means from the system or to the system. Okay, the simply your system is balloon over here. Okay, so one kid is doing this particular playing whatever this activity. He has taken the balloon, he blown the air, and he released the air. That means mass going out. And again he want to pump more air. And again he is taking that balloon. Okay, and again he is blowing it. Okay, and now air is going in from his mouth. Like that, mass can transfer on both the sides. Okay, from the system and energy also. Okay, energy also. Suppose see, you have one container. Okay, in that container, otherwise simply one bucket of hot water. Okay, one bucket of hot water. You are leaving in the bathroom. Okay, and then you are late for bathing. Okay, you are late for bathing. What will happen? After some time, the water quantity will be remain same, but heat, you can sense that your water is at relatively low temperature. Okay, at the initially the water was upon the stove or wherever, it was a certain situation like it is boiling. Okay, now after some time of 10 minutes, okay, you are late for bathing. Because of that, the water temperature is low, relatively set in 80 degrees, okay, or 70 degrees. What happened over there? That heat energy is transferred to the surroundings. Okay, heat energy transferred to the surroundings. Here, whatever, I'm sorry, whatever heat energy or mass transferring from the system, okay, through whom it is passing? Obviously through the boundary. In case of your hot bucket of water, okay, the passing through your bucket surface also. That is your boundary. Yes, that's what. If a system is there, from the system, mass can, from the system, mass can transfer, okay, and energy also can transfer. Okay, based upon this, mass transfer and energy transfers, whatever is happening, okay, based upon this, here we have divided the system into three different types. One is closed system, the second one is the open system, and third one is the isolated system. Okay, closed system, open system, and isolated system. Okay. Okay, so let us stop here. Okay, and then next class, let us start from here again. So because this is the beginning part, and again I repeat this particular system, okay, for only for few minutes. Then let us see what is the closed system, open system, and isolated system. Okay, fine.
Sir,
Yeah,
do you have the PDF of the book you are telling about?
yeah, I have. I'll share with you.
Okay, sir.
Okay, I'll be dropping in our Teams only. Okay.
Actually, sir, I'm not added to the team, so maybe I can take my from friends.
Pardon?
I am yet not added to the teams.
I'll add. Don't worry. I'll add
Okay, sir.
everyone. Whoever this number, registration number will be increasing, then I'll be adding one by one. Okay.
Okay, sir.
So
Okay,
don't
sir.
worry. Okay, so then I'm posting this particular PDF in the Teams itself. Now itself I'm posting. Then you can read that book also. Anyhow, this presentation also I'll be posting. Okay. After next class, then I'll post this even present. All the presentations also will be given to you. No need to worry about that also. Okay. Yeah.
Okay,
And
sir.
this is the 4 credit course. We have 3 lectures and 1 tutorial. Okay. So let us plan tutorial in the first class. Okay. But next week, let us continue with our theory part only, because we have not discussed very much to go up to the problem stage. Okay. The next class, also next week completely, let us discuss theory part. Okay. From that, whatever this first class will be there on Wednesday. So that class, let us solve some problems. Okay. Okay then. Bye bye.
Sir,
Yeah, please.
sir, can you tell about the marks distribution or the how the exams will be conducted?
The exams actually, this is the central exam, I think so, right? So one common question paper will be coming to all.
No, like how many exams? Only two exams, mid or end.
That
Like,
I'll find out. Actually, I need to talk to the main coordinator. Okay, Professor Subhranshu Roy, senior most professor in the department. He is the coordinator for this course. Okay, so first I need to talk with him. Then that's what even today class I have not mentioned about these all things, marks distribution and all. Okay, certainly certain assignments will be there. For that also, Weightage will be there. Even some class tests also will be there. Probably the final exam actually will be centralized. I hope so. Okay. Otherwise, maybe during present situation, that also might be changed. That I don't know. I need to discuss with Professor Subhranshu Roy. Yeah, I'll let you know. Don't worry about that. Okay. So don't worry about grading and all. So we are doing our best. Okay. So panel is open all the time. Whatever the doubt you will be getting, you can simply write in the Moodle itself. Okay. So then whatever the time I have convenient, then I'll be responding to you. Okay. And even if any other students also knowing about this particular answer, whatever the question raised by, then you can type there itself, like discussion forum. Okay. Okay, then see you next class. Yeah, bye
Thank you,
bye.
sir.
Thank you. Thanks a lot.
Thank you,
Thanks.
sir.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.